So let's begin with chapter number 16, that is a recovery system. In the last class we have discussed some topics of this chapter, that is chapter number 16. Today I'm going to continue with the same chapter but the new topics, that is how to make the locking protocol, how to use a two-phase locking protocol. So chapter number 16, that is a recovery system. Just introduction of this one first of all. So what is a system first of all? That is a grouping of the interdependent components. So when we combine multiple interdependent components together, that makes a system. And if using that components to recover any data or recover any information, that is a recovery system. So there are so many data that is lost during the during the theft, natural disaster. So it's a mandatory, or it's a, we can say, the condition that is used to apply the system that is used to recover the data from the backup devices, that is done by the recovery system. So we have studied about the recovery schemes that is available that can restore the database to the consistent state, that is state that is exists before the failure. So if a failure occurs, whatever the state that is before the failure, that has come up with the recovery schemes. And the main advantage of recovery scheme is that it provides a higher availability, that the data is available back to the recoverable or consistent state. And one of the another advantage that it minimizes the time for which the database is not usable after a failure. That is, the time is not we can say wastage for a failure or after a failure. Then we have studied about the failure classification, that is what is the failure classification, what types of error that is available in the failure classifications. So there are basically three types of or four types of errors that is available. One is only the transaction failed, that is the whole transaction failed, that is a transaction failure. That contains a logical error as well as a system error. That means if there is any error in the programming term, syntax term, that is a logical errors. And if there is any error in the transaction, in the, we can say, the state of the transaction, for example, if a deadlock happens or occurs, that is a system error. And there is a system crash, that is the whole system crash due to the hardware malfunctioning or the bug that is available in the database software, that is system crash. So one is transaction failure, that contains two parts, logical error, system error. There is system crash. And next is a disk failure, that is the disk of the system is failed. It may be any disk, that it may be a DVD, CD-ROM. So action must be taken to recover the data from the database, recover the data from the recovery schemes. So action must be taken during the normal transaction processing to ensure that enough information is available to recover from the failure. That is, enough information or sufficient information is available after the failures. And the next point is action must be taken that the failure is used to recover the database and provides the asset property of the database, that is the atomicity, consistency, isolation, and the durability. That is the asset property of a database. Then there are three types of storage that is available. One is the volatile storage, non-volatile storage, and the stable storage. And we mainly focus on the stable storage because the data is stable, data is constant in the stable storage. And that contains the form of the database management, or we can say the database storage, that is a RAID, that is a redundant array of independent disk that is used to recover the data in case of the disaster such as the fire or the flood. And there will be a remote backup also that is available online. And what is we can say that whenever we transfer the data between the memory and the disk storage, that can result in the successful completion, partial failure, or the total failure. So that may be a full completion, or we can say the full data is recovered from the database, or there may be a partial failure that occurs, that some data is recovered and some data is not recovered, and there is a total failure, that is, and no one nothing or data is available in the database failures. And these are the three steps that is available how to make the database recoverable. Then next is the how to access the data, that is the data access. There are different blocks that is available, so we can divide the memory into different chunks, different blocks, that is a fixed length block that is known as the blocks. And there are physical blocks, buffer block, and as well as the disk blocks. And there is the input and the output also. Input transfers the physical block into the main memory, and the output transfers the buffer block into the disk memory. This is a diagram that shows which is the main memory and which is the disk. And there are multiple operations by which we can transfer the data from the between, we can say, the any two operations, that is between the disk and the database, or the database and the disk, and from the backup to the database. There are two operations by which we can carry it out, that is a read operation and the write operation. Read means only we can read the data but cannot modify the data. Write means we can read the data as well as modify the data, that is a edit or edit the data. Then there is a recovery and the atomicity, that is how to recover the data and how to provide the atomicity in the database management system. Then next is what are the log records. So whatever the content or whatever the we can say the sequence that is available, that is any modification, any editing in the database is identifying the log fields, that is the log records, that recovers all the updates activities in the database. And there are multiple types of log records. An updated log record describes a single database slides, and these are the various fields in the log records. First of all, the transaction identifier, that identifies the transaction, that is a unique identifier of the transaction. Then data item identifier, then the old value and the new values. And there are three types of, we can say, the operations, that is the start operation, commit operation and the abort operation. Start means the transaction has started the work. Commit means the transaction TI has commit, that is it has run the work. Abort means in between, due to some error, the transaction aborted or does not work furthermore. Then there will be a database modification, that is how to make the database modification, that is done by using the log records, that allow the system to undo or redo the systems or redo the transactions or changes. That is, we can undo the transactions or undo the changes, or we can also redo the changes that is made by a transaction in case the event has been aborted, that allows the system to redo the changes that is made by a transaction. So there are two types of modification techniques that is available. One is a deferred modification technique, one is the immediate modification technique. And the deferred modification has an overhead. The transaction needs to make local copies of the updated data item that is available. And in case of the immediate, that is immediate action will be provided, or the transaction readouts in the updated form, that is updated, it must read the values from the local copies, that is the immediate modification. And there is a recovery algorithm that is also taken into account various factors. There are multiple factors that is taken into the recovery algorithm, and there are two operations that is performed that allows the database modification. One is the undo, that uses the log record threads to identify the data item that is specified in the log record to the old values. Then redo means that sets the data item specified in the log record to the new value. Undo means using the old values, and the redo means using the new value. Then there will be a concurrency control and the recovery, that is how to control the concurrency operations, or we can say when more than one transactions are executing at the same time, how to control them, that is a concurrency control. And how to recover the data whenever there will be any failure or the error or any bug that is occur in the database. So that is a recovery concurrency control and the recovery schemes. There will be a transaction commit also, that is commit means the transaction is done or everything is okay with the stable storage, everything is done with the stable storage, that is the transaction committed. Then using the log record to redo and undo the transactions, that is how to redo the operations and how to undo the operations. And undo means the rollback the transaction during the normal operations, and redo means again repeating the same transaction to the new value, that is the redo operations. And this is the portion of the log record that is available. This is one part, that is a T0 that starts, then T0 that gives the value of the A and the B transaction, then commit, then again T1 starts, give the value of the C, that is the 700 and the 600, then T1 commit. That is a portion of the system logs corresponding to the T0 and the T1. Then T0 is the read A, then A equals to A minus 50, then write, then read B, then B equals to B plus 50, then write B. So this is the transaction that is occurred. That is, there are two operations. One is the redo operation, one is the undo operations. And this is a redo, that is sets the value of all data items updated by a transaction TI to the new values. Then there will be undo, that is TI that restores the value of all data item updated by the transaction TI to the old values. That is, undo means going back to the old values, redo means going back to the new value, that is a redo operation. And after a system crash has occurred, the system consults the log to determine which transaction needs to be redone. That is, after any crash has been occurred, the system determines which transaction needs to be redone and which needs to be undone as to ensure the atomicity. That is, which to be undo, which is to be redo, as to ensure the atomicity of a transaction. This is the same log, that is at different times it is uses. Then there will be a checkpoint. That is also one of the important point. That is when the system crash occurs, the checkpoint is also used. That is, till that point we have occurred or the data will be saved. That is a checkpoint. And after that the data will not saved. And if there is any system crash occur or disk failure occurs, system failure occurs, then after that checkpoint the data will be lost. And before that checkpoint the data will not lost. That is a checkpoint. That is a margin. That is that point by which or from which or to the point of which we can save the data. That is, the data is saved. So in case of failure occurs, so there is no, we can say, the duplicacy of the record. There is no record that is available. That is a checkpointing. And one of the difficulties or two of the difficulties that is available in this checkpointing is that this is very time consuming process, and most of the transaction is using is to be redone have already written their updates into the database. That is a this process, that is a checkpointing process, is very time consuming process, and most of the activities that is using in this algorithm needs to be redone their update into the database. Although redoing them will have no harm, but it have a less chances of recover to take the longer times. And these are the various operations that can be performed by the checkpointing. First of all, it gives the output to the stable storage. That is, every log records is residing in the main memory. Then output to the disk every modified buffer blocks. Then output on a stable storage to the checkpoint, where the L is a list of the transaction that is active at the time of the checkpointing. That is, it provides the output on the stable storage, or we can say the log records on the stable storage. One of the important concern is that transactions are not allowed to perform any update information, any update actions such as the writing or the reading into a log block while the checkpointing is in progress. While the checkpointing is in progress, while the checkpoint is currently going on, there is no update, there is no written work, there is no reading work that allows the transaction to make the checkpointing. And again, this is the redo and the undo operations that can be applied on the checkpointing also. So these are the two operations, that is a basic operation that can be applied on any method of the transaction. That may be a checkpointing, that may be a stable storage, but these are the two we can say the operation that is common to each and every operation, that is the undo and the redo. Undo means going back to the old values, redo means going to the new values. Next is the recovery algorithms. That is, what are the various algorithms, what are the various sequence of steps available to recover from the database, to recover from the failure that is occurred after the failure. That is a recovery algorithm. So until now, in discussing recovery, we identified the transactions that need to be redone and those that need to be undone. That is again the same. Undone means the undo operations, redo means the redone operations. Then there will be a transaction rollback. That is, whenever there will be a normal operation that is taken place, there will be a transaction rollback. That is, the transaction is going back to the normal operations that is performed. That is, it is a scan backward for each log of the activity to maintain the log records of the transactions. Then how to recover after a system crash. That is, if the full system crashes, so how to recover after a system crash. These are the again the two methods that is used. One is the redo phase, one is the undo phase. When there will be a buffer management, that is how to manage the buffer that is available, that is how to manage full-fledged activities that is carried out in the transaction management. So in this section we consider several subtle details that are essential to the implementation of a crash recovery scheme that ensures data consistency and imposes a minimum amount of time or overhead on the transaction with the database. That is, there will be a minimum amount of time that is required on the database, that is interacting with the database. The first is log record buffering. That is every log record that is available, that is contained in the buffer management, there will be management of the buffering that is available in the log record buffering. But the main limitation is that the cost is very high in case of the log record buffering. This is one of the example that is available in the log record buffering. There is a WAL, that is a write ahead logging. Then there will be a database buffering, that is the full database will be buffered. Then again, there are multiple policies that is available in this one. One is a no steal policy, there will be a steal policy. Then what is the operating system role, that is what is the OS role in the buffer management. that makes or that reserves part of the memory to serve as a buffer rather than the operating system manages. That is, every part is managed by the main memory but not the full-fledged, or we can say the operating system itself. And there will be a swap space also. That swap is the memory, or that swaps the space, that is the data will be transferred from one place to the another place. Then there will be a fuzzy checkpointing, that is the checkpointing that generates by the modified buffer blocks, that is known as the fuzzy checkpointing. Then failure from the loss of the non-volatile storage, that is how it is possible, that is using the entire content of the database to the stable storage periodically. Now next is the how to release the early logs and the logical undo operation, that is if there will be a undo operation, that is how to release the undo operations to into the and convert into the redo operations. So if there is any index that is maintained, such as in the B plus tree that is available, that can be treated as a normal data, but to increase the concurrency we use the B plus tree concurrency control algorithm that allows the data to be released, or that allows the logs to be released early in a two-phase manner. That is, we have studied about the two-phase locking protocol that is used to early release the system or logically undo the operations. For example, there are two transactions that is performing, transaction T1 and the transaction T2, and how to release the logs that is available in the T1 and the T2, and how to make the undo operations. So these are the recovery algorithm that is used to support the early log release. So one is a logical operation that is used, that is how to use the early how to use a logical operation such as the AND gate, NOR gate, NOR gate, and the XOR gate that is available to in the logical operations to make sure that the logs will be released at the early stage. And the operation that requires a low level logs that while they execute but releases them when they complete, that is until and unless the logs are not available, they are not, we can say that they are not going back, they are not released earlier. This is one of the example that is given whenever there will be insert operation in the B plus tree. And there is another operation that is used when that is a logical undo operations, that is that undone the work that is used by converting the new values into the old values, that is the logical undo operation. Then how to undo the logical log record, that is the logical undo log records that allows the undo of the operations before an operation is performed to modify. This is the syntax that is used, that is a TI OJ operation build. And there will be a logical logging also, there will be physical logging and the physical log records. And whatever the operation that is used, whatever the content that is used, that is where there are various operation logging of the information about the operation, that is a logical logging, and the logging of the old values and converting from the old values to the new values information, that is known as the physical logging, and the corresponding log records are known as the physical log records. There will be a logical, there will be a physical, and there will be a physical log records. Then transaction rollback with the logical undo, that is how to perform the transaction rollback with the logical undo operation, that is also used. So first of all, the physical log records are encountered during the scan are handled as described earlier in the we can say we can use the physical log record that is generated by the operation. Completed logical operations identified by operation and records are rolled back in a different way. Whenever the system finds a log record, TIOJ operation, and you take the special action that is available that rollbacks the operation by using the undo operation, undo information that is available in the log records. As the backward scan of the log continues, the system skips all the log records of the transaction until it finds the log record, that is the TI and the OJ. This is one of the, we can say, the diagram that shows that is how to use the transaction rollback with the logical undo operations. That is this is the activity of the T0, that is the transaction 0. Then next is the transaction 0, then T1, T1, then there will be a logical undo of the O0 or O1 that add the 100 to the C that performs undo operations. That is the T0 decides to abort. That is the transaction rollback with the logical undo operations. Then what are the various concurrency issues that is available in the logical undo operations? So whenever there will be we are using the logical undo operation, so there will be a concurrency, that is more than one transactions uses the same values, that is the old values, that is the logical undo operations. So there will be a low level logs that is available during an operation that are sufficient to perform a subsequent logical undo of the operations. If both the original and the logical undo operations access a single page, that is also known as the concurrency, that is controlled very quickly so that the transaction does not affect by this provision or by with this facility, that is a combination of the original operation and the logical undo operations. And there will be a multi-level recovery also, that also relaxes the locking requirement that is used in the transaction controls. Now next is the ARIES, that is available, that is also one of the recovery method that is used, that is the ARIES, that is the ARIES. Now this is a recovery method that is used by the recovery method or the ARIES recovery method. This technique is described in the last chapter also, on the last 15th chapter also, along with the logical undo logging scheme that is described in the 16.7. So ARIES uses a number of techniques to reduce the time taken for recovery. The main target is that, the main concern is that how to reduce the time and how to make or how to provide the full efficiency or full accuracy while recover from the database, recover from the backup, recover from the failures. So ARIES uses the or takes the less time as compared to other techniques to recover the data and to reduce the overhead of the checkpoint. In particular, ARIES is able to avoid redoing many logged operations that have already been applied and to reduce the amount of information logged. The price that is paid is greater complexity, that is whatever the price that is paid is of greater complexity, the benefits are worth the price. So whatever the benefit that is available, whatever the price that is available in the high benefits. The major difference between the ARIES and the recovery algorithm that is described in this these 2 points that is available. One is the ARIES, one is the recovery algorithm. So first of all, it uses the LSN, that is a log sequence number, that identifies the log records, that stores the LSN number in the database pages to ensure that to identify that which operations have been applied to the database page. Then it supports physiological redo operations that are physical in the affected page, that is physically identified but can be logical within the page. Then there will be a dirty page table to minimize the unnecessary redos during the recovery. And as mentioned earlier, dirty pages are those pages that have been updated in the memory and the disk version is not up to date. Then uses a fuzzy checkpointing scheme that records only information about dirty pages and associated information and does not even acquire or require the writing process. So there will be a LSN, that is a log sequence number, to identify the log records and store the LSN in the database pages. Then supports the psychological redo operations. Then uses a dirty page table to minimize the unnecessary redo during the recovery. Then next is the data structure, that is what is the data structure of the ARIES, that is recover from the database. That is every log record in the ARIES has a log sequence number that uniquely identifies the record. So this is a unique number that is available to identify the records, and the ARIES can be split a log file into the multiple log file, each of which has a file number. And when a log file grows to some limit, ARIES appends further log to the new log file. The new log file has a file number that is higher by the one than the previous log file. And each page also maintains an identifier that is known as the page LSN, that is identifier that uses a page that carries out the page, or that we can say the identify the page, that is known as the page LSN. Whenever an update operation that is used that occurs on a page, the operation stores the LSN of its log record in the page LSN field of the page. That is whatever the field that is available, that will be available in the page LSN field of the page. During the undo operation or redo phase of the recovery, any log records with the LSN less than or equals to page LSN of a page should not be executed on the page, since their actions are already reflected on the page. In combination with the recording page LSN as a part of the checkpointing that is used in this one. And the page LSN is essential for ensuring the impedance in the presence of the physical or psychological redo operations. And there will be a CSR or CLR, that is a compensation log record, that is also available in the ARIES, that is uses the CLR method, that is how to abort the method, how to get the method, how to access the method in the database systems. This field serves the same purpose as the operation identifier in the operation abort log file in the earlier record files. This is the database buffer, this is a log buffer, this is a stable data, this is a stable logs. And dirty page table contains a list of pages that have been updated in the database buffer. For each page, it stores the page LSN and a field known as the rec LSN, which helps identify log records that have been applied already to the version of the page on the disk. A checkpoint log record contains the dirty page table and a list of the active transaction that is available in the database systems. So that is a checkpointing that is used, that is done by the recovery system, that contains the dirty pages, that we can say the dirty page table, and consists of the active pages that is used in the database management. Figure 16.8 illustrate that is how to use the dirty pages, how to use the management of the dirty pages. So every page or each page has been associated panel LSN field that is used to identify what are the various updated pages, what are the various algorithm that is used in the updated pages. Then there will be a recovery algorithm that is also used, that is how to recover the database or how to recover from the dirty pages. That is a recovery algorithm. And ARIES recover from a system crash in 3 passes, or the 3 passes in which the ARIES recover from the system crash. So one is the analysis phase, one is the redo phase, one is the undo pass. So there are 3 phases in which the ARIES recover from a system crash, that is the analysis pass, redo pass, and the undo pass. Analysis pass means this pass determines which transaction is used to undo, which page were dirty at the time of the crash, and the LSN from which the redo pass should start. That is the analysis pass. That is the analyze the data. That is the analysis phase. That is how to make the database or how to use the database. That determines, that is how to undo the operations, and which pages were dirty at the time of the crash. That is which pages are available at the dirty point that is used in the database recovery management. Then there will be a redo pass that starts from a position determined during the analysis, that is used, that performs a redo, repeating history to bring the database into the consistent state before it was crashed. Then undo means roll back the transactions that were incomplete at the time of the crash. So there are 3 operations: one is analysis, one is the redo pass, one is the undo pass. So let's start, or let's discuss one by one in detailed manner. So first is the analysis pass. That is, the analysis pass finds the last complete checkpoint log record and reads in the dirty page table from this record. It then sets redo LSN to the minimum of the rec LSN of the pages in the dirty table or dirty page table. If there are no dirty page tables or there are no dirty pages, it sets the redo LSNs to the LSN of the checkpointing log records. The redo pass starts its scan of the log from the redo LSN. All the log record that is used earlier from this point have already been applied to the database pages on the disk. And the analysis pass initially sets the list of the transaction that is to be undone, undo list, to the list of the transaction in the checkpoint log records. The analysis pass continues scanning forward from the checkpoint. So whatever the scanning point, whatever the checkpointing that is used in scanning forward, that is used in a scanning format from the checkpointing. And whenever it finds a log record for a transaction not in the undo list, it adds the transaction to the undo list. The analysis pass also keeps tracks of the last record of each transaction in the undo list that is used in the undo pass. And the analysis pass also updates the dirty page table whenever it finds a log record for an update to a page or on a page. If the page is not in the dirty page table, the analysis pass adds it to the dirty page table and sets the rec LSN of the page to the LSN of the log records. Then there will be a redo pass that repeats the history by replaying every action that is not already reflected in the page on the disk. That is, repeat each and every operation or replay each and every item or action that is not already reflected in the page on the disk. So recover all the item that is not already recovered from the disk, that is not already reflected in the page on the disk. The redo pass scans the long or the log forward from the redo LSN. So whatever the redo information, whatever the redo pass, that scans the log forward from the redo LSN. Whenever it finds an update log records, it takes this action. So whatever the action that is taken, so it performs the action. So if the page is not in the dirty page table or the LSN of the update log record is less than the rec LSN of the page in the red table, then the redo pass skips the log record. So if the page is not available in the dirty page table, the redo passes the or skips the log record. Then there will be undo pass and the transaction rollback. That is relatively straightforward. It performs a single backward scan of the log, undoing all the operations in the transactions in the undo list. And whenever an update log record is found, it is used to perform an undo operation that is used for the rollback during the normal transactions. And there will be a CLR that is also generates a that is also used to generate that contains a various algorithm that contains the undo action that is performed by the logical AND. This is the end of the log at the crash that is used as a checkpointing. And another features or the another important feature that is available in the areas that is as follows. First is the nested top action. So next one of the another feature is that there will be a nested top action that is available that allows the logging of the operation that should not be undone even a transaction gets rolled back. That is a nested top action that is available. That is we can log the information. We can log the information that is contained in the database transaction even if the transaction gets rolled back. For example, if a transaction allocates a page to a relation, even if the transaction is rolled back, the page allocation should be undone since other transactions have been stored in the page. Such operations that should not be undone are known as the nested top action. So whatever the operation that is not going to the previous state, not undone the values, undone the records, that is known as the nested top actions. Such operations can be modeled as operations whose undo action does nothing. Then there will be a recovery independence. That is there will be a recovery independent means the recovery is available or independent from all the material, all the things that is available in the some reasonable parts. Then there will be a save points that the transaction can record the save points and can be rolled back partially up to a save point. So transaction can record the save point that is occurred or that is available in the save pointing mode. This can be quite useful for a deadline handling since transaction can be rolled back to a point that permits release of the required logs and then restarted from that point. So whatever the point that is available, we can restart from that point, that is a save point, like a checkpointing that is used. Now next is the fine grained locking. That is also one of the feature that is available, or that is we can say that gives that is also given by the Aries. So that is a fine grained locking, that is we can grain the or we can use the fine grained locking, that is the index control locking that uses in the content of the locking mechanism. Then there will be a recovery optimization. So there will be a recovery optimization, that is we can recover the material, we can recover the content in an optimized manner so that it is available in the content of the database. Now next topic is remote backup system. So what are the remote backup system? That is the online system that we already discussed some point, that is one or 2 points about the remote backup system, that is the online system. So traditional transaction processing systems are centralized or client server systems. So traditional transaction processing system that is available, that is known as the centralized system or the client server systems. Such systems are vulnerable to the environmental disaster. So whenever we use a client server system, they are not more resistant, they are not fully, we can say, the protective from the flood or the natural disaster, that is a flood, fire, earthquake, tsunami, and so on, natural calamities. Increasingly, there is a need for the transaction processing system that can function in spite of the transaction failures or environmental disasters. So there is a need for the transaction processing systems. There is a need that the transaction will be processed in a proper manner so that the recovery can be done or the transaction is recovered from the system failures or environmental disaster. Such systems must provide the high availability. So that is a system that provides the high availability, that the data is available in a consistent manner, in an atomicity manner. That is the time for which the system is usable or unusable must be extremely small. That is the time that is taken for the system that is extremely small for the database systems. We can achieve the high availability by performing the transaction processing at one site, that is a primary site, and having a remote backup site where all the data from the primary site are replicated. So everything is available at the remote site, but there will be a duplicate data, there will be a duplicate site that is available, that is known as the secondary site, or we can say the remote backup site that is used on that contains the duplicate data as contained in the primary site. And the remote site must be synchronized. So that means every updation that is made in the primary site must be updated in the secondary site. So it must be synchronized with the primary sites as updates are performed at the primary. We achieve the synchronization by sending all the log records from the primary site to the remote backup site. The remote backup site must be physically separated from the memory. So whatever the memory site, whatever the backup site that is available, that is separated from the primary files or primary sites. For example, we can locate in a different state so that a disaster at the primary does not damage the remote backup site. This is the primary method, this is the backup method that is available, this is the network, this is the log records, this is the primary network backup. So whatever the primary data that is available, that will be backed up from the data. That is the architecture of the remote backup process. When the primary site fails, if this site fails, the remote backup site takes over the processing. First of all, it performs the recovery using the copy of the data from the primary site. So whatever the data that is available, it takes the data from the primary sites and the log records received from the primary. This is a log record that is received through the network. In effect, the remote backup site is performing recovery actions. So then the remote backup site that is used, that is performing the recovery action that would have been performed at the primary site where the latter recovered. Standard recovery algorithms with minor modifications can be used for recovery at the remote backup site. So the standard recovery algorithm that is available, that is also used at the remote backup sites. Once recovery has been performed, the remote backup site starts processing transaction. So this is the idea that is used. So this is the primary site. When this does not work, the log records will be contained or will be going to the through the network that is used or that is used by the backup site to take the backup, to give the backup to the primary data. Once the recovery has been performed, the remote backup site starts processing the transaction. Now, availability is greater emphasis or increased over a single site system. So there will be a greater data available that is used in the single site system. So the system can recover even if all the data at the primary site are lost. So if every data is lost in the primary site that is available, but the backup contains the data or backup provides the data that is available, so every data is contained or every data is available from the backup sites. So several issues must be addressed in designing a remote backup system. So these are the various issues, or we can say the challenges that is faced while designing a remote backup systems. One is the detection of a failure. So it is important for the remote system to detect when the primary has failed. So it is not that the primary has failed, the remote backup does not know that the primary has failed. No, that is not the case. But this is very essential that if the primary has failed, so it is able to detect by the remote backup system that the primary has failed. Failure of our primary lines can fool the remote backup into believing that the primary has failed. To avoid the problem, we maintain several communication links with independent modes of failure between the primary and the remote backup. For example, several independent network connections, that is including perhaps a modem connection over a telephone line, may be used. So there are multiple independent network connections that is used, that is a modem connection, for example the telephone line that is used. These connections may be backed up via manual intervention by operators who can communicate over the telephone lines. Next is the transfer of the control. So these are the challenges. So there will be a detection of the failure, that the data will be detected if the primary sites fail. Then there will be a transfer of the control, that the control automatically transfers from the primary site to the backup sites. So when the primary sites fails, the backup site takes over processing and becomes a new primary sites. When the original primary site recovers, it can either play the role of the remote backup or take over the role of the primary site again. So if the primary site has failed, the data will be, or the control will be transferred to the backup site, and after the recovery, or after the, we can say, the primary sites recovers, then again it is playing the role of a primary site, then again the data will be transferred. So in either case, the old primary must receive a log of the updates that is carried out by the backup site while the old primary was down. The simplest way of transferring control is for the old primary to receive the redo logs from the old backup sites. Then next challenge that is used, that is the time to recover. So it takes more time to recover the data from the remote backup storage. So if the logs of the at the remote backup grows largely, the recovery will take a longer time. So there will be a longer time that is taken by the recovery system. Then hot spare configuration, that takes the takeover of the backup site, that is used in the instantaneous ways. Then there will be a time to commit. So there will be a, it also takes the time to commit the protocol or time to commit the transaction. To ensure that the updates of committed transactions are durable, a transaction must not be declared committed. So whenever there will be update of a committed transaction that is a durable, the transaction must not be declared committed until its log records have reached and the backup reached the backup site. This delay can result in a longer wait to commit a transaction, and some systems therefore permits lower degree of the durability. The degree of the durability can be classified as follows. So this is the degree of the durability that is available. One is a one safe durability. Then there is a two every safe durability. So one is a one safe, then the two very safe, then there is a two safe. These are the three types of durability that is available. So one safe means a transaction commits as soon as its commit log is written to the stable storage at the primary site. Then two very safe, that is a transaction commits as soon as its commit log is written to the stable storage at the primary and the backup site. And two safe, that is a safe or the same for the two very safe if both the primary and the backup sites are active. And several commercial shared disk systems are available that is used, that feels a level of the fault tolerance that is intermediate between the centralized and the remote backup systems. And this is the winding up of the chapter. That is what we have covered in the recovery systems. So that is this is a summary of this chapter that I'm going to take after the break. So let's take a break right now, then moves to the summary, then finishes this chapter. So let's take a break. Now come back from the break. Now let's start the session again. So this is the summary that is left for this chapter, that is chapter number 16. So what is the summary? The first point says a computer system, like any mechanical device, is subject to the failure. That is failure is very we can say the common error that is found in the failure that is used. There are variety of causes of the failure that is occurred. That is, there are different failures that is used in the system crash. That is, there are many crashes that is available in the system failures. For example, the transaction failures can occur, the system crash occur, and there, in case of the failure, in each of the case, the information concerning the database system is lost. So whatever the data that is available, whatever the information that is available, that is lost in the database systems. In addition to the system failure, the transaction may also fail for various reasons, such as the violation of the integrity constraints. So the integrity constraints may be violated in case of the data failure, system failure, and there will be a deadlock condition that is also occurred in the database system. So that is there will be a deadlock, that is also one of the category of the system failure, by which the system can corrupt, by which the system fails. That is a system failures. So next is the any integral part of our database system is a recovery system that is responsible for detection of failure and for restoration of the data item that is used to the existence that storage that is used in the database manufacturing database systems. The various types of data storage that is available in a computer are the stable or volatile storage, non-volatile storage, and the stable storage. So there are three categories of the storage that is used. One is the stable storage, one is the non-stable storage, one is the volatile storage, one is the non-volatile storage, one is the stable storage. And the data that is available in the volatile storage, such as the RAM, are lost when the system crashes. So whatever the content that is available in the system crashes, that is recovered, or whatever the content that is available or that is lost in the RAM, that is available in the volatile storage, that is we can say the lost whenever the system crashes. So whenever the system crashes, the data will be lost, and the data in the non-recoverable system, that is the non-volatile storage, such as the disk, are not lost when the system fails. So when the system fails, that is not lost if the data will be stored in the non-volatile storage, but may occasionally be lost because of the failure such as the disk crash. Data in the stable storage are never lost. So whatever the data that is available are never lost. Next point says the stable storage that must be accessible in line or online is approximately with mirrored disk or other form of RAID will provide redundant data storage. So stable storage that is available online that is approximated with used with the mirrored disk that is used with other forms of RAID also that provides a redundant data storage. Offline or the archival data that is used, for example, the stable storage may consist of the multiple tape copies of the data that is stored in the physically secured location that is used in the physically stored location. The next point says, in case of a failure, the state of the database systems may no longer be consistent. So in case of the failure occurred, the state of the system database system that is available may longer be consistent. That is, it may not reflect a state of the world that the database is supposed to work. So it may not represent a state of the world or state of the, we can say, the world that database is supposed to capture. To preserve the consistency, we require that each transaction be atomic. That is, a transaction is atomic that is used. That is the responsibility of the database system, recovery system, to ensure the atomicity and the durability property. Then there will be a point that is a log-based scheme. That is, every update is available in the database scheme that must be kept in the stable storage. And when we say that a transaction is committed transaction, that means it has been recorded the log records, and there will be a commit log record for the transaction that has been output to the stable storage. Then next point is log record contains the old values as well as the new values, and there are two operations that is used for making the or using the old value, that is the undo operation, and then redo operation that is using the new values. And the new values are used in case the updates need to be redone after a system crash. So if the system crashes, the new value will be taken up, that is to be redone in the system crashes. The old values are used to roll back the updates of the transactions in case of the transaction abort. So if the transaction aborts, the old values must be updated in the normal execution. Then there are two types of modification that is covered, that is a deferred modification and the intermediate modification. So in the deferred modification, during the execution of the transaction, every write operation are deferred until the transaction has been completed. So until the transaction has been committed, every write operation must be deferred, or going on till the time the transaction is committed, at which the time system uses the information that is used with the transaction is deferred writes. And there is the intermediate write, that is every time the write operation is used, the transaction commits. Again write operation, again transaction commits, again and again. That is every time when the transaction occurs any modification, any editing, so any write operations, every time the transaction has been committed. Next is to reduce the overhead of searching the log and the redoing operations. So to reduce the overhead operations for searching the log files and for searching the redoing operation transaction, we can use the checkpointing technique. So there is a checkpointing technique that is used to search for the log file and redoing the transaction, that is reducing the overhead of the checkpointing, reducing the overhead of the logging point, redoing transaction, that is known as that is done by the checkpointing techniques. Then modern recovery algorithms are based on the concept of repeating history, whereby all the actions taken during normal operation. So the modern recovery algorithm are used whenever there will be a repeating history, whenever all the actions are performed are taken during the normal operations. Repeating history restores the system state to which it was the time the last record was able to or output to the stable storage that is used before the system crash. And undo is the operation that is performed from this state by executing an undo pass that processes the log records of incomplete transaction in the reverse order. That means undo means going back to the reverse order, that is going back to the log record of the complete transaction in the reverse order. Then undo operation write out the special redo operation only log records and the abort log records. After that, the transaction can be completed or considered to have completed and will not go undo again. Then next is the transaction processing is based on a storage media. So whenever the transaction processing takes place, that is based on the storage model in which the main memory holds a log buffer, database buffer and the system buffer. So these are the three types of buffering that is available. One is a log buffer, one is a transaction buffer, one is a database buffer, one is a system buffer. And the system buffer holds the pages of the system object code, that is the executable file, and the local work areas of the transactions. The next point is efficient implementation of a recovery scheme requires that the number of writes to the database and to the stable storage be minimized. So whatever the writes that is available to the database, whatever the write that is available to the stable storage can be minimized. The log records may be kept in a volatile log buffer initially, but must be written into the stable storage when one of the transaction condition occur. So if one of the transaction condition occur, it must be going into the stable storage when these conditions can occur. So before the TI commit, log records may be output to the stable storage. All log records pertaining to the transaction TI must have been output to the stable storage. And before a block of data in the main memory is output to the database, all the log records pertaining to the data is the block that is output to the stable storage. Then next is the modern recovery technique supports high concurrency logging techniques. So another techniques that is available for the recovery algorithm, or that is used for the recovery techniques that supports the high currency logging techniques, such as those used for the B plus tree concurrency control. This controls allows early release of low-level logs obtained by the operation, such as the inserts or the deletes. That is, every insert operation, every low-level insert operation that is used, that is obtained by the operation, such as the insert or the delete operations, which allows other such operation to be performed by other such actions or transactions. After lower level logs are released, physical undo is not possible, and instead logical undo such as the deletion to undo is an insertion is required. Transactions retain high level logs that ensure that the concurrent transactions cannot perform actions that could not or that could make logical undo of an operation impossible. Then the next point is to recover from the failure that results in the loss of the non-volatile storage, we must dump the entire content of the database onto the stable storage periodically. So recover from the failure that results in the loss of the non-volatile storage that is used to dump the entire content of the database into the stable storage periodically, say once every day. So recover from the failures from the non-volatile storage, we recover the data onto the stable storage in a once per day or once at any time once in a day. Then there will be a next protocol, the next method that is used, that is the ARIS protocol. That is a recovery scheme, that is a scheme that supports a number of features to provide the greater concurrency control, greater logging overheads, and the minimize the recovery techniques. It is based on the repeating the history. The history will be repeated again and again and again, and also allows a logical undo operations. And this scheme also flushes the pages on the continuous basis and removes the database onto the content that is available, and do not flush all the pages at the time of a checkpoint. And it uses the LSN, that is a log sequence number, to implement a variety of optimization techniques that reduces the time taken for recovery. So it implements a variety of the optimization techniques that is used that reduces the time taken for the recovery. Then next is the remote backup, that is the last point, that provides a high degree of availability. So whenever there will be a remote backup, we are using the remote backup. So the availability is very high in case of the remote backup as compared to the archival backup, that is the offline backup. That allows the transaction processes to continue even if the primary site is destroyed by a fire, flood or earthquake. That is, the transaction processing is going to continue even if the natural calamities occur like the fire, flood or the earthquake or tsunami, and any natural calamity that is occurred. Data and the log records from our primary sites are continuous back to the remote backup. So if the primary sites fail, the remote backup is available to give the backup. If the primary site fails, the remote backup takes over the transaction processing after executing certain recovery actions. So this is using the certain recovery action that is used for the algorithm, that is used by the algorithm. Next is the review terms, that is there are various terms that is available, that is the review terms. This is the recovery scheme, then the failure classification, then blocks, then fail stop assumption, then disk failure. These are the review terms that is available in this chapter, that we have covered in this chapter actually. And these are the various practice exercises that is explain why there is a need for the log operation, why there is a need, why the log records for the transaction are on the undo list must be processed in the reverse order. That is, what is the reason why undo is going for the reverse order. So according to the name, it name advice undo, that is undoing the work, that is going back to the reverse operation, reverse order, where the redo is going into the forward direction, forward operation. Now next is explain the purpose of the checkpoint mechanism, that is what is the role of the checkpoint mechanism, that is a point that is used from where or to which the data will be saved. After that, if the failure occur, the data will lost, but before that, if the failure occur, the data will saved. Next question, these are the various questions. State the deferred modification technique that is used. This is a question, that is a transaction deletes a record and the free space generated thus is allocated to the record inserted by the another transaction even before the first transaction commit. What is the problem behind this? And explain the reason why recovery of the interactive transaction is more difficult to deal with, that is the recovery of the batch transaction. So if there is a recovery of the interactive transaction that is taken place, that is dealt with the recovery of the batch transactions. The next question is how to undo the operations, how to redo the operations, how to make the modifications of the operations. Now next is the exercises, that is explain the difference between the three types of storage, that is the volatile, non-volatile and the stable. Volatile, that the system loses the content whenever there will be a disk failure. Non-volatile, system does not loses the content, and the stable, that is stable in terms of the data access. Now these are again the questions, that is the Aries question that is available. Now this is the bibliographic notes. Now next is the part 5. So we have also finished with the part 4 also, that contains 3 chapters, chapter number 13, 14, 15 and 16, that is the transaction and concurrency control, and the last chapter is chapter number 16, that is the recovery management. Next is the part number 5, that is the system architecture. So Larry, shall I proceed with the part 5 or shall I continue in the next class? All right. So I'm taking this part 5 in the next class, that is in the tomorrow's class. So if there is any doubts, you can ask the doubts from me regarding chapter number 14, 15 and 16. That's the transaction, concurrency control and the recovery management.